About the design of slabs. So slab is one of the structural element in the building. So structural element in the building which covers a floor or roof of the building. So first of all, whenever we are going for a design of any building, we always first of all we have to design the slab. So because of load is transferred from the slab, then another structural elements. That's why we always design for the consider the first element is slab. So in this slab, what are the different types of slab is available used? We are for the design such that one-way slab, then two-way slab, then continuous slab, then cantilever slab, then flat slab, then flat plate. So these are the types of slab. So in some such condition is there for considering whether it is a one-way slab or two-way slab. If it is a one-way slab, the condition is, so consider this is a slab. The slab having a two span is there. One is longer span, another one is a shorter span. So longer span we consider as a L suffix y direction, whereas x is a in another direction. So in this condition, Ly by Lx, which is greater than 2. If it is greater than 2, that such slab we call it as a one-way slab. So example for one-way slab is veranda slab. So veranda slab only the longer span will be maximum when compared to the shorter span, which is the condition of greater than 2. So whereas two-way slab is condition is so vice versa, Ly by Lx less than 2. So greater than 2 means one-way slab, less than 2 means two-way slab. Then continuous slab is so more than one support we call it as a continuous slab. So this is the slab, the support is more than one, so 2, 3, 4 support is there along with the beam, we call it as a continuous slab. So more than one slab we call it as a continuous slab. Then cantilever slab, which is having a support of only one portion, we having a support another direction which is having a free. So that's why, so this is the cantilever. Then flat slab without projection of beam we consider as a flat slab. So flat slab is without projection of, for the we need a more ceiling space, then only we go for a without beam. That slab we consider as a flat slab. So for the use of maximum utilize of spacing of that ceiling area, height of the building. That's why that purpose, elevation purpose or on elevation purpose, and then the portion of that utilizing of the building. And flat plate is nothing but the thickness of the slab is very minimum when compared to the flat slab. So this is the different types of slab: one-way slab, two-way slab, continuous slab, cantilever slab, flat slab, then flat plate. So these are the types of slab. Design of slabs as per the IS 456 design requirements. We will this is the IS 456. So IS 456 2000. Plain and reinforced concrete code of practice. So this is the code book which we are going to use for the design of structural elements. So in that, for the slab design requirements, we have to go to the page number 46 and 48. So these are the design requirement which is available in your IS 456. We will discuss here. So first of all, first one is minimum reinforcement. So that is the conditions we have to provide at least, so which is referred in page number 48 IS 456 para 26.5.2.1. So in that the discussion is minimum reinforcement is nothing but if we are using mild steel, if we are designed for the slab, if we are going to use mild steel means we have to provide at least 0.15% of cross section of the slab, that is a depth into that thickness. So mild steel if you are using not less than 0.15% of cross section, whereas if you are considered for HOSD bars we have to provide at least 0.12% of cross section. So comes to the diameter of the bar for the using of slab, we have to, which is referred in page number 48, 26.5.2.2. The diameter of the bar should be not greater than 1/8 of total thickness of the slab. In case of, if you are using 160 mm thickness of the slab divided by 8, which is 20 mm diameter have to be used. So that is the condition. So that's why the condition is not greater than the 1/8 of total thickness of the slab. So we should not use more than 20 mm. Next, how much the cover spacing we have to provide. So cover is shall not less than 20 mm or diameter of the bars, whichever is higher. In case of, if we are using 16 mm dia bar, the shall not less than 20 mm when compared to the 16 mm, which is higher. So 20 mm is higher, we have to use 20 mm. That is the cover. Cover is nothing but the spacing between one reinforcement to another reinforcement. That is reinforcement to concrete. Reinforcement to concrete, we call it as a cover. So that condition is there. Next, maximum spacing. This one is reinforcement to reinforcement, we call it as a spacing. So spacing, which is mentioned in page number 46, 26.3.3 under the category B, subdivision of B, for the main reinforcement. So reinforcement we always provided for one direction of main reinforcement, another direction we provide the distribution reinforcement. So condition for main reinforcement, it should be not greater than 3 times of diameter. 3 times of diameter. If you are using 20 mm dia bar into 3, so 60 mm should it is not greater than that 3 times of D. That is a spacing. The spacing between 3 into 20, 60 mm. When comes to so here when the D is depth, not the diameter of the bar. D is depth. So effective depth in case of 150 mm means 3 into 150 for 450. Here 300 mm, another conditions. So along these two, whichever is smaller, 450 or 300 mm. So 300 mm is smaller, we have to use 300 mm spacing between reinforcement to another reinforcement for the main reinforcement, not distribution reinforcement, main reinforcement. The second one is distribution reinforcement. Second, distribution reinforcement should not greater than 5 times of effective depth. 5 times of effective depth. In case of, if you are using effective depth for the if you are using 10 mm bar, so like that, if you are using same 20 mm bar, 150 means 5 into 150, almost 750. Then another one is 450 mm, whichever is smaller, 450 is smaller. So we have to adopt 450 mm spacing between distribution to distribution. So these are the conditions, these are the requirements for the design of slabs. So once we go for a design of slabs, we always keep it in mind. These are the IS codes recommendations. So it should satisfy the following conditions.